Intervals and tests. This is a lot of information that we already learned with proportions, but it still holds true for means. So we're going to run through it real fast. Confidence intervals and hypothesis tests are built from the same calculations. That's why both this test rejected the null of 10 ounces, and so does this interval. This interval rejects the null of 10 ounces because 10 is not in the interval. So that's what we mean when we say they're built off the same calculations and they make the same conclusions. However, they won't make the same conclusions if you don't use the corresponding alpha level or confidence level. So to understand that, you need to know what links with what. For a two-tailed test, the confidence level, no, the alpha level, the alpha level is equal to the complement of the confidence level. So 1 minus alpha will give you the confidence level. So for example, a 95% confidence interval matches an alpha of 5% for a two-tailed test. But for a one-tailed test, we're only looking in one direction. And this 5% for a two-tailed test is split over the two edges. So if you have 95% in the middle, then that leaves you 2.5 and 2.5 on each edge. That's your alpha for a two-tailed test. But if it's a one-tailed test and you're only looking in one direction, then the alpha level is equal to half of the complement of the confidence level. So for example, a 95% alpha level, confidence interval would match an alpha level of 2.5% because you're only looking at one of those tails, either the less than or the greater than. So for this one, we used an alpha of 5%. We built a 95% confidence interval is what we did. That would match an alpha of 2.5% because this was a one-tailed test. So this would reject at the 2.5% level. Now the p-value was small enough to reject at smaller levels as well. That just means if we went up to a 99% confidence interval, we would probably still reject, okay, because this p-value was really small. But at a 2.5 alpha level, this confidence interval would make the same decision as this test. When using a confidence interval in place of a hypothesis test, just simply look to see if the null value is in the interval. If it is in the interval, you cannot reject it, or the sample does not show evidence for the alternative. Does not. If the null value is not in the interval, then we can reject the null and conclude that there is evidence for the alternative. So you still need to do O and M, but you're not talking about a p-value. So if you use a confidence interval in place of the test, you do O and M, but you're not talking about a p-value in those sentences, but rather you're looking to see is the null in the interval. That's what you do in place of comparing a p-value to an alpha level. Sample size. So just like we did with proportions, we can set up an equation to find our sample size. To find the sample size needed for a particular confidence level with a particular margin of error, you would need to solve this formula for n. So this is the margin of error. The margin of error is the part behind the plus or minus. There's a big problem here though, because if we need to solve for n, then that means we need to know s, and that means we need to know t star, which is based off of n minus 1. So the problem is we don't know any of those values. If we don't know n, then we don't know our sample size. And if we don't know our sample size, then we obviously don't have a sample. And if we don't have a sample, then we don't have a sample standard deviation, and I can't figure out which t star I'm supposed to use because I don't know n. So I don't know any of these numbers. That's a problem. So you need to make sure you understand what we do in place of this. Number one, for proportions, if we had no clue what p was, we used 0.5 because that was right in the middle. Well, standard deviations can go anywhere from 0 to infinity. So there's no right in the middle number. So we have to have some clue what S is. I'm going to have to tell you in the problem what to use for S. That's number one. Have to have some clue for S. We cannot figure out T star. There's no way around it. We will use Z star in its place. We will go back to Z star. Remember, those are across the bottom of the T table, the very last row. We'll go back to using a Z star in its place. Remember, sample size calculations are never exact. So even if I want the margin of error to be, say, 5, and I solve this formula and I get a sample of, you need a sample of 100. So I go out and collect 100 pieces of data, and then to build my confidence interval. My margin of error might not be exactly 5. It's just a good place, a starting place. It's better to know you need 100 versus needing 1,000. Like, you need to know where you are. The margin of error after you collect the data won't match the one you use to find N exactly. The sample size formula depends on quantities we don't have until we collect the data, but using it is an important first step. Before you collect the data, it's always a good idea to know whether the sample size is large enough to give you a good chance of being able to tell you what you need to know.